we're going to start off what I'm going to consider the easiest rational function I can have you graph, and that's going to be y equals 2 over x minus 4. Right? Doesn't get easier than this. Right? You've got a nice number on top, nothing tricky going on the bottom, and so we're going to talk about how to handle this, and how do you actually graph this? So how do you graph it? Well, we're going to identify the same parts that we've done in the past. We've got vertical asymptotes, we've got a horizontal asymptote. I want x-intercepts and y-intercepts and a hole, right? See if there's any holes in here. And we start. First thing we do, vertical asymptote, whatever makes the bottom 0. So in this case, we're going to have vertical asymptote at x is equal to 4. Horizontal asymptote, this is bottom heavy, so we're going to have a horizontal asymptote at y is equal to 0. As far as finding an x-intercept, if I try to set this equal to 0, there's no way it equals 0, so there's going to be none for the x-intercepts. As far as y-intercepts, when I plug 0 in for x, I end up with 0. I end up with 2 over negative 4, which gives me a negative 1/2. And there's nothing that cancels, and since there's nothing that cancels, there's no holes. And so we have our very basic graph. How do you go about graphing it? Well, we deal with the asymptotes. You get a vertical asymptote at 4. So I get to draw my dashed line at 4. I get a horizontal asymptote at y equals 0, and so I get a horizontal line at y equals 0. I have pretty much no other information other than y-intercept is 0, negative 1/2. Now I've done a whole lot of talking, right? And here's what I need everybody to do at this point, right? First, everybody should have a sheet of paper out because you need to be drawing this. If you think you're going to learn this just by watching, it's going to get very complicated pretty quickly in the next few examples, and you need practice drawing. So, what I want everybody to do, oh, whoops. Okay. How do you graph rational functions? And the biggest thing you have to worry about is how do you deal with vertical asymptotes? Right? That's the major issue. How do you deal with vertical asymptotes? And what happens with vertical asymptotes is, the great thing about vertical asymptotes is the line either goes all the way up or it goes all the way down. It never comes to the middle and stops. And that means if you're coming from the left side, it's either going to go up or down. If you come from the right side, it's either going to go up or down. And your job is to figure out what it's doing. At the vertical asymptote, is it going up or is it going down? And here's how you answer that. Here's how you find out that question. And I'm sorry, this part is tedious, but this is what you have to do. You have to plot points on the left and the right of the asymptote. And when you plot points on the left and right of the asymptote, that's going to tell you where the graph is going. So, here's my vertical asymptote. And so what I'm going to do is do a little XY chart. And on my little XY chart, I'm going to pick x values that are to the left and the right of the asymptote. So if I'm sitting at 4, I need to pick 3, and I need to pick 5. So I'm going to pick 3, and I'm going to pick 5. And so, how do I do this? Well, let's say if x equals 3. So what I have to do is plug the 3 into my function. So I go over here. If x is 3, well, that's 2 over 3 minus 4, and so that gives me a negative 2. If I plug 5 in, well, let's see, it's going to give me 2 over 5 minus 4, which is going to give me positive 2. Okay, something that we haven't had to do, but we are going to have to do from this point forward, is given, if you've got a vertical asymptote, you've got to find out what's happening on the left and the right. So we pick x values to the left and the right of the asymptote. That's where the 3 and 5 came from. And plot points, and so now I'm going to plot points. So at 3, I'm at negative 2. So here I am at 3, I'm down at negative 2. And at 5, I'm at positive 2. And at this point, everybody should have this picture. Even if you don't have grid paper, you should have this picture on your paper. Because this next part is actually how you graph. And it's really easy, right? It's incredibly easy, but I need you to do it along with me. And here's how it works. Horizontal asymptotes are actually called, they're even called end behavior because that's where the graph ends. Here's how we use horizontal asymptotes and vertical asymptotes to generate a picture. What I want everyone to do, right, once you've got this picture, is I want you to put your pencil on the horizontal asymptote. Technically, it's a little bit above or a little bit below. You get so close you can't tell. Just put your pencil on the asymptote, right? And now what you're going to do is you're going to take your pencil and you're going to draw along that horizontal asymptote towards the points that you plotted. So the way that works is I'm going to start here, and then I'm going to go along towards this point. So I see this point, and I see this point's going down. And then I have to make a decision, and my decision is, all right, I've got a vertical asymptote. I'm either going up the wall or down the wall, and based on how I'm drawing, this looks like I'm going down the wall, and so I'm going to go down the wall. And so now I've drawn this part. Right? So now I've got the left part. Now I'm going to go to the right. When I go on the right, again, I put my pencil on the asymptote. I don't worry about if it's above or below. I just go ahead and put my pencil on the asymptote. And then I sort of hang at the asymptote as long as I can, and then I have to head towards the point that I plotted. And so if I start here and I hang at the asymptote, and then I see that I've got this point, I started to curve up, and so this is telling me which way I should go in the vertical asymptote. In this case, it says I'm going up, and so I have my picture. And now I have successfully drawn this. Now, if you're curious, as my high school self would have been, but again, I'm weird. Where is this? Right? Let's plot a new function, and we're going to plot, what was that, 2 divided by x minus 4. And there's the actual picture. Are we perfect? No. But we're close, right? Yeah, probably could have been a little neater there, probably could have been a little neater there. I'm not after perfection here. What I'm after is, do you have the asymptotes in the right spot, and are these swoops in the right spot? So, this is the easiest version, right? Okay, so now let's see what happens when things get a little bit harder. So, let's see, I'll go ahead and delete this because I don't need that anymore. And I'm going to erase this. And so now we start with, I want to graph y is equal to x plus 1 over x squared minus x minus 6. So, everybody write that down. And just for fun, right, because even though we may not be able to graph this yet, let's talk about what our vertical asymptotes, horizontal asymptotes, X-intercept, Y-intercept, and holes are. And what I want So this was a little different than the previous problems because if you go, like the first thing you should do whenever you have things like this is factor, right? So when I go through and factor this, I get x plus 1 over x minus 3, x plus 2. So So I factor, nothing cancels, so I don't have any holes. But you get vertical asymptotes anytime the bottom equals 0. And in this case, I have two places where the bottom equals 0, so I have a vertical asymptote at x is equal to 3 and at x is equal to negative 2. That part's different, right? That's not something that we dealt with at the beginning of the week. Horizontal asymptote, this is bottom heavy, so it's going to give us y is equal to 0. X-intercepts are set the top equal to 0, and the top is going to equal 0 at negative 1. So we're going to have an x-intercept at negative 1, comma 0. As far as y-intercepts go, when I plug 0 in for x, these cancel out. I'm going to end up with a y-intercept at 0, comma negative 1/6. And since nothing canceled out, there's no holes.
Mr. Office,
Yes?
how do you know there's no horizontal asymptote and it's 0?
Oh, well, how do you tell the difference? All right.
Yeah.
If it's top heavy, there's no horizontal asymptote. If it's bottom heavy, the horizontal asymptote is 0.
Okay.
All right? And we're going to talk about top heavy in just a minute. But right now, here's bottom heavy, here's our information, there's no hole. And so even if you had trouble generating this information, make sure you have this information now, because now we're going to draw this. Again, if you don't have graph paper, that's fine, but you still need to start drawing because what we're about to do is going to help figure some stuff out. All right, so we have two vertical asymptotes. So we have a vertical asymptote at 3. We've got another vertical asymptote at negative 2. Right. And we have a horizontal asymptote at y equals 0. Looks like we've got an x-intercept at negative 1, 0. So I've got an x-intercept at negative 1, 0. I'm going to put that in black so it hopefully sticks out. We've got a y-intercept at 0, negative 1/6, so that's like here. All right, and that's all the information we have. All right, and somehow from this we are supposed to generate a picture. Good luck, right? We don't have enough information. So what we do have are these vertical asymptotes, and we have to find out what's happening on either side of the vertical asymptote. Meaning, when I look, when I see this asymptote at negative 2, I need to find out what's happening on the left and the right of this. So I'll make up an XY chart, and I'm going to plug in negative 3 and negative 1. We already know what happens when we plug in negative 1, but that's okay. And then at this vertical asymptote, I've got to figure out what's happening on either side of that. So it looks like a 2 and a 4. All right. So what do we do? Well, we've got to plug these in. So I've got to plug this thing back into my function. I always like using the factored version. Somehow I find it easier. So I'm going to plug all these values in. You already know when we plug negative 1 in, we get a 0. So I don't have to worry about that one. But when I plug negative 3 in, let's see. Negative 3 plus 1 is negative 2. Negative 3 minus 3 is a negative 6. Negative 3 plus 2 is a negative 1. And that's going to give me negative 2 over 6, so I get negative 1/3. Make sure I get that right. Negative 2, I'm fine with that. Negative 6, 91, okay. So at negative 3, I'm at negative 1/3. So that's down here. We already know this one. Next, I got to plug 2 in. So when I plug 2 into my function, let's say 2 plus 1 is 3. 2 minus 3 is a negative 1. 2 plus 2 is 4. And this is going to give me negative 3/4. And then I need to plug 4 in. So when I plug 4 into my function, 4 plus 1 is 5. 4 minus 3 is 1. 4 plus 2 is 6. So I end up with 5/6. And unfortunately, this is tedious. I know it's tedious, but you have to do it. Otherwise, you're not going to come up with a nice picture, or you're not going to be able to generate a picture. All right, so I've already handled the negative 3, negative 1/3, the negative 1, 0. I need to handle these two things. So at 2, I'm at negative 3/4. So it's like here. And at 4, I'm at 5/6. So 5/6 is a little less than 1. And so now what I need from everybody, right? Even if you had even if you had difficulty coming up with this, and you know these numbers were really ugly and I went through them too fast, I need to make sure that everybody has the two vertical asymptotes, the horizontal asymptotes, and then you have a dot that's at negative 3, negative 1/3. You have a dot at negative 1, 0. You have your y-intercept, which is at 0, negative 1/6. You got another dot that's at 2, negative 3/4, and you have a dot at 4 and 5/6. All right. And once you have those dots, you have enough information to you have enough information to come up with this picture. And we can actually come up with a fairly accurate picture, which is kind of scary, right? And so here's how you do it. Right? We kind of do the same thing. We put our pencil, right, on the horizontal asymptote. Right? I don't know if it's slightly above or slightly below, but I put my pencil on the horizontal asymptote. And I head towards the first dot. And as I head towards that first dot, I have to sort of notice, am I going up the wall or down the wall? And if as I look at this, I'm heading towards that dot, because that dot is a little bit below, this is telling me I'm going below. I'm going my vertical asymptote, I'm going, because I'm starting to go down, that means I go down the wall. And so I have this part. And then over here, I do the same thing. I put my pencil on the horizontal asymptote and I start heading towards my first point. And as I go towards that first point, I notice that that first point is above the horizontal asymptote. And because it's above, that's telling me that I go up. And you might look at this and say, well, that's kind of similar to the last problem, because like one part did a little swoopy thing that was below and one part did a swoopy part that was above. But then you might think, well, what's going on in the middle? And here, you're going to have to take my word for this. The reason you need to take my word for this is there's just an experience, just when you graphed enough, when you've plotted enough of these things, you know what happens in the middle. And so what I'm going to do is tell you what happens in the middle. There's literally 4 things that can happen in between vertical asymptotes, right? And I'm going to draw them for you. Here are the 4 things that can happen when you have, this is the 4 things that can happen inside vertical asymptotes. Okay? So thing number 1, right? So here I'm going to do a little cheat sheet. Here's my, here I'll draw it off to the side. I'll put it where it connects, where it's lit up. Okay? So here's my vertical asymptotes, here's a horizontal asymptote, and so one thing that can happen is you get something that looks like this. I would say it's a parabola, but it's not quite a parabola because it goes straight up. Parabolas don't go straight up, they kind of curve up. So it goes straight up and straight up. So you could have a little parabola that sort of curves up. That's one thing that can happen. Another thing that can happen inside 2 vertical asymptotes is, well, you could have a, let's say that's your horizontal asymptote, you could have a parabola looking thing that curves down. So in between vertical asymptotes, You can either have something that curves up or something that curves down. All right, so there are 4 things. These are 2. All right? Here's the other 2 things. One of the other 2 things, you've got 2 vertical asymptotes. You can get an S-looking shape in the middle, where on this side it goes up and this side it goes down. You're still got those walls of the vertical asymptote, but you can have an S shape that decreases. And similarly, over here you can have an S shape that increases. All right? And anytime you have 2 vertical asymptotes, one of those things is going to happen. You're either going to have like a U-looking thing, either going up or going down, or you can have an S-looking thing, either going up or going down. And it's your job, based on the information, to figure out what's happening with it. Also, notice that if you have a horizontal asymptote, if you have those S-looking things, it crosses a horizontal asymptote. Horizontal asymptotes talk about end behavior. They're telling you where the graph goes all the way to the right, and they tell you about the graph when it goes all the way to the left. Horizontal asymptotes don't tell you a thing about what's happening in the middle. So, is it possible to cross a horizontal asymptote? Yes, it is, and a lot of times it does happen. Vertical asymptotes you don't cross, but horizontal asymptotes you do cross. And there's some ways that I can write questions where they cross multiple times, but I'm not worrying about that today. All right, so now, how do we figure out what this does? Well, the way I always think about it is I do kind of look at where my dots are in relationship to the horizontal asymptote. So this one, because this dot is below the horizontal asymptote, that tells me that this part is going down. Right? And what I can see as this goes down, this goes here, and a lot of times you'll get a dot down here, and then you'll get a dot up here, and then it's very obvious what's happening. This one's not as obvious, but typically whenever you have a dot that's like your dot is on the horizontal asymptote, that means that the graph is going to go through it, which means if I connect these dots and it's an S-shaped, it's going to look something like this. And so now we have our lovely picture, and I am very curious. Let's see just how close I actually got. So this is an x plus 1. Divided by x squared minus x minus 6. And if you look, I'm not perfect. That's pretty close. This one, I could have done a better job getting closer to getting to that vertical asymptote, and I probably could have done a little better job here. But the goal here isn't to be exact. I mean, to be exact, you'd have to plot a whole bunch of points. We didn't plot a whole bunch of points. I mean, we had to plot. I mean, I basically plotted 5 total points, and 2 of them were easy. But this is what happened when I have this is what happens when you have 2 vertical asymptotes. All right? So that's how we handle 2 vertical asymptotes. I have another example, but I want to get to something else. So I may come back to another example that has 2 vertical asymptotes, but right now I'm going to move on to the next problem. So here's my next problem. And my next problem is going to be, let's do x squared plus x minus. x minus 3. And so here's what I'd like everybody to do. I want everyone, given that, write down all the information you can about vertical, horizontal asymptotes, x-intercepts, y-intercepts, and holes. And I'm going to write that information. What we have. Actually, not that bad. We go through. I'm going to factor this. And so when I factor it, it's x plus 3, x minus 2, over x minus 3. Nothing cancels, but it's kind of what happens. We get a vertical asymptote at x is equal to 3. It's top heavy, so there's no horizontal asymptotes as far as finding x-intercepts. We're going to have x-intercepts at negative 3, 0, and 2, 0. As far as y-intercepts go, when I plug in 0 for everything, I think I end up with a y-intercept at 0, 2. This cancels. Negative 6 over negative 3 just gives me a positive 2. There are no holes because nothing canceled. All right. So we've got our information, and let's plot that stuff. Let's plot our information. So when I plot my information, I get a vertical asymptote at 3. So there's my vertical asymptote at 3. X-intercept at negative 3, 0, at 2, 0. Oops, 2, 0. Say y-intercept at 0, 2. Okay. So, okay, what good does that do? All right, so we got a vertical asymptote. We've plotted x and y-intercepts. What do we do, right? I mean, we could plot something. Oh, shoot, I need to move this down a little bit. I forgot. Sorry, I'm going to move. I'm just going to tell you I know something about what this is going to look like at the end, which is why I've got to shift this down. So let me go through and plot this stuff again. Negative 3, 0, 2, 0, and 0, 2. All right, now we're good. And we got to figure out, well, what happens. We've got a vertical asymptote, so we can plot some points. Fortunately, we only have one vertical asymptote, so I just need to plot a point to the left and plot a point to the right of it. So if I'm at 3, I need to talk about 2 and 4. 2 I've already taken care of, that's easy. 4, a bit of a pain. If I do 4, let's see, 4 plus 3 is 7 times 2 over 1, so it's going to give me 14. So at 4, here, make these dots black so we can see them. And at 4, I'm all the way up at 14. And from this information, I'm supposed to come up with a picture. And I don't see how to do that, right? I don't have enough. There's something weird going on, but how do you handle it? Well, so we're going to pause right now, right? And we're going to go review a topic that seems to have doesn't seem to have anything to do with this particular problem. So if you're saying, where the heck is this coming from? Don't worry, your math teacher's just crazy. So what I'd like you to do is I want everyone to do a division problem. I want everyone to do x squared plus x minus 6 divided by x minus 3. And to be honest, do synthetic division. Right? And just curious, everybody unraise your hand so if you've got your hand raised, here, let me pause this for a second. So you bring the 1 down, 3 times 1 is 3, add 1, that gives us 4. 3 times 4 is 12, we get a 6. And so when we do this division, we end up with x plus 4 plus 6 over x minus 3. Does everybody kind of remember that? We do our division, and we get this part. All right, so what does this have to do with this, right? What does doing any kind of division help us do anything with graphing? Well, what you just did, you may not believe this, actually. So what we're about to do is I'm introducing something called a slant asymptote. So this is a horizontal asymptote, right? It goes horizontally. Whenever something's top heavy, right, you get a slant asymptote, right? And what I'm about to do is explain how you find the slant asymptote. Now, I'm giving you the theory behind it. What I'm going to do is give you the theory, explain why it works, and at the very end of it, I'm going to say, if you understand that, great. If you don't understand that, this is what you do to find the slant asymptote. So you don't have to understand why it works to actually find it, right? But here's why it works. The first thing is this division problem is the exact same thing as x squared plus x minus 6 over x minus 3. I mean, that's what this means. And when you do the division, you say this equals x plus 4 plus 6 over x minus 3. That's what the synthetic division means. These are equivalent, right? I am changing the way this looks to make it look like this, right? Right? Great. So what does that have to do with anything? Well, when you are talking about horizontal asymptotes, that's really something called end behavior. What happens at the end? When I say what happens when x gets big, I'm asking the question, all right, when x is huge, like this is x is 10, here's x is 20, if I kept walking, I'd get x is 100, keep walking, get x is 1,000, get x is 1,000,000. When end behavior is answering the question, what happens to the graph when x gets huge? And actually, more to the point, it's what's important when x gets huge. See, when we were doing those previous problems, like when you find out that, when we go through and find out when you find your horizontal asymptote, you say, well, what's the most important term on top? Meaning that this x and this negative 6 don't matter because x squared matters when x is huge. Same thing down the bottom. What's our most important term on the bottom? Well, the 3 doesn't matter when x is huge. So horizontal asymptotes, they're talking about end behavior. What happens when x gets big? Well, a slant asymptote does the same thing. What happens when x gets big, or what's important? Another way of thinking about what's important is what doesn't matter, right? Like the 6 and the x didn't matter, the 3 didn't matter, right? So what we've done is I've rewritten this, right? There was my original equation. And so I've rewritten this as y equals this, right? And I still ask the question, what happens when x gets big, or what doesn't matter when x gets big? So when x is huge, x is still x. This matters. When x is huge, 4 is still 4. It matters. When x is huge, 6 over x minus 3, when x is huge, this expression gets really small, meaning it doesn't matter, right? So when x is huge, this doesn't matter, and we're left with y equals x plus 4, right? Now, this is what the graph is going to behave like when x is huge. All right, now, if you understood what I just said, awesome, great. If you didn't understand what I just said, don't worry. To find your slant asymptote, the way you have to find your slant asymptote is you have to do synthetic division, or you do a division and ignore the remainder. So as long as you know how to divide, as long as you know how to divide, you can find your slant asymptote. So we don't have a horizontal asymptote, but we do have this thing we do have a slant asymptote, and my slant asymptote is going to be y is equal to x plus 4. And how we deal with that is, well, we're going to graph it. So if it's y equals x plus 4, that says y-intercept of 4, slope of 1. Okay, so it goes up 1 over 1. Uh-oh. Move some things that I did not mean to move. Okay. Okay, so this was at 14. This was at 2 and negative 3, and this was at 2. Okay. And so here is my lovely slant asymptote. And so here's what we have. All right. So now I have my vertical asymptote and I have my slant asymptotes, and I have some dots, right? And somehow, if I've got my asymptotes plotted and I've got some dots plotted, I should be able to come up with a picture. Now, just like when you have two vertical asymptotes, there's certain things that happen in between. Anytime you have a vertical and a slant asymptote, there's 4 things that can happen, and what I'm going to do is draw those 4 possible outcomes, and then we're going to see which one matches this picture. Okay. So, outcome number 1. If you've got a vertical asymptote and a slant asymptote, one outcome is it could look like this. Right. So vertical asymptote, slant asymptote. Sometimes you get the graphs in the 2 sort of big parts. Sometimes, if you've got a vertical asymptote and a slant asymptote, you get a picture where the graph is in the 2 small parts. Sometimes when you have a vertical asymptote and a slant asymptote, you get in the big part and the small part. And sometimes when you have a vertical asymptote and a slant asymptote, it goes on the bottom half of this, and so it looks like this. So whenever you have a slant asymptote, one of these 4 things happen. And so now we have to figure out which one of these 4 things happens here, and even if we figure out what happens here, how do you draw it? So here's how you draw it. Right? So first, I need to make sure, even if you've been a little confused up until this point, I need to make sure you've got, you've drawn a rough sketch of the vertical, the slant asymptote, and these dots. Right? Right? So if you've got, it doesn't have to be perfect, you just have to have something that looks like this, because now I'm going to show you how do you draw given this information. Now, when we were graphing using horizontal asymptotes, remember I said we put our pencil on the horizontal asymptote? Well, slant asymptotes are still, horizontal asymptotes are in behavior, slant asymptotes are also in behavior. So what I want everyone to do is put your pencil on the slant asymptote. Right? Technically it's a little above or a little below, I don't care. You put your pencil on the slant asymptote and at the edge, and then you head towards the dots that you've plotted. And so if I put my pencil on the slant asymptote and I start drawing to these dots that I've plotted, and now I'm here, well, now if you've got a vertical asymptote, you either go up the wall or down the wall. I think it's pretty obvious we're going down the wall, so I'm going to go back down the wall. All right? Now this next part's a little tricky. Right? So again, you put your pencil on the slant asymptote, and you stay with the slant asymptote, and then At some point, you have to hit this, you have to curve to hit this dot. So we go, I have no idea how far down I need to go, and then I curve, and then I start to go up. Now, slant asymptotes are very tricky to graph because some of you are going to do this and go ahead and start curving and hit the point here. Some of you are going to go way down and curve and go up. And to be honest, you don't know where that little peak is. There's no way that you're ever going to find it without plotting a bunch of points, and that's not what I wanted. What I wanted was you sort of draw down, I want to know that it's in this little part, this little small area. And even this one, I know it looks like it has a peak here, but again, I don't know exactly what it is. But just for fun, I want to plot a new function. So what's that? X squared plus x minus 6 divided by x minus 3. There's the actual graph. Did I get it right? Not exactly, right? If I look here, I went down too far. It sort of curved ahead. I don't care about that. I just care that we have this little swoopy thing here. For this one, I started here, made it hit these points, but notice it's peaked right around here. I didn't get it right. I don't have to. I want to make sure I get the right shape.
How did you get x plus 4 for the horizontal asymptote?
You had to do the synthetic division. So if you do this division problem, and then when you do the division problem, ignore the remainder. Right? So anytime something's top heavy, you do the division and ignore the remainder, and that gives you your slant asymptote. So, all right.